Hi, I'm Bob. Welcome to the Solutions to Microeconomics course. Thank you for solving the exercises with me in the past few months and joining my YouTube channel. We arrived at the last part of Chapter 7 about the firm's cost of producing multiple goods. Let's find answers to the exercises together. Here's exercise 5.1. What can you say about Laura's economies of scope if her time is valued at $10 an hour and her production possibility frontier is ppf1 in figure 7.10? Since Laura's production possibility frontier is ppf1, concave to the origin, she enjoys the economies of scope. We can calculate the measure of the degree of scope economies. Suppose Laura works 8 hours per day. She can collect 8 pints of mushrooms. The cost of collecting mushrooms separately is $10 per pint. Similarly, the cost of collecting strawberries separately is $13.33 per pint. Laura can collect 6 pints of mushrooms and 4 pints of strawberries jointly. The cost is $80. If she collects them separately, the cost will be $113.33. Substituting the cost values into the measure of the degree of scope economies gives a positive number. It is cheaper to collect the 2 goods jointly. It saves $33.33 per day compared to collecting the goods separately. Let's solve exercise 5.2. A refiner produces heating fuel and gasoline from crude oil in virtually fixed proportions. What can you say about economies of scope for such a firm? What is the sign of its measure of economies of scope? SC. The firm has economies of scope because it is less expensive to produce heating fuel and gasoline jointly than separately. If gasoline is produced separately, the firm has to throw away the heating fuel that comes as a side product. Thus, the cost of producing them separately would double the cost of producing them jointly. The sign of the measure of the degree of scope economies, SC, is positive. Let's find answers to exercise 5.3. According to the researchers, the United Kingdom started regulating the size of grocery stores in the early 1990s, and today the average size of a typical UK grocery store is roughly half the size of a typical US store and 2/3 the size of a typical French store. What implications would such a restriction on size have on a store's average costs? Discussed in terms of economies of scale and scope. If a firm has economies of scale, its average cost decreases as output increases. If a firm has economies of scope, the cost of producing goods jointly is lower than producing them separately. Generally speaking, larger stores sell more goods than smaller ones. If the stores have economies of scale, the average cost decreases as more goods are sold. The restrictions on the size of the stores will raise the average cost of the products. Larger stores also sell a larger variety of goods. The cost of selling different goods in one store is lower than selling them in different stores if the stores have economies of scope. The restriction on the size of the stores will also raise the average cost of selling products. Let's jump to the challenge of this chapter. In the challenge solution, show that for some wage and rental costs of capital, the firm is indifferent between using the wafer handling stepper technology and the stepper technology. How does this wage cost of capital ratio compare to those in the C2 and C3 ISO cost lines? If the firm is indifferent between using the wafer handling stepper technology and the stepper technology, the ISO cost line must touch both technologies. It is the ISO cost line C4. C4 is flatter than C2, but steeper than C3. The size of the slope of the ISO cost lines is the wage to the cost of capital ratio. So, the wage to the cost of capital ratio for C4 is smaller than that for C2, but larger than that for C3. Let's try exercise 6.2. If it manufactures at home, a firm faces input prices for labor and capital of W and R and produces Q units of output using L units of labor and K units of capital. Abroad, the wage and cost of capital are half as much as at home. If the firm manufactures abroad, will it change the amount of labor and capital it uses to produce Q? What happens to its cost of producing Q? The slope of the ISO cost lines is the negative of the wage to the cost of capital ratio. It remains unchanged if producing abroad. If the production function is the same, then the cost minimizing bundle of inputs, A, is unchanged. The cost identity shows that the cost of producing a given level of output Q is reduced by half abroad. Let's solve exercise 6.3. A U.S. synthetic rubber manufacturer is considering moving its production to a Japanese plant. Its estimated production function is a Cobb-Douglas form. In the United States, W equals 10 equals R. At its Japanese plant, the firm will pay a 10% lower wage and a 10% higher cost of capital. What are L and K? And what is the cost of producing 100 units in both countries? What would be the cost of production in Japan if the firm had to use the same factor quantities as in the United States? By the tangency rule, the wage to the cost of capital ratio equals the marginal product ratio. We obtain K equals L. Substituting it into the production function gives the cost minimizing bundle of labor and capital. Both are 10 units. The cost is 200. In Japan, we use the same method to find the cost minimizing bundle of labor and capital. the firm uses more labor and less capital. Although the firm uses a different factor ratio in Japan, the cost is the same as in the United States. If the firm has to use the same factor quantities as in the United States, the cost will be 200.91, which is higher than the cost using the optimal levels of inputs. Let's go to exercise 6.4. A U.S. apparel manufacturer is considering moving its production abroad. Its production function is a Cobb-Douglas function. In the United States, W equals 7 and R equals 3. At its Asian plant, the firm will pay a 50% lower wage and a 50% higher cost of capital. What are L and K? And what is the cost of producing Q equals 100 units in both countries? What would be the cost of production in Asia if the firm had to use the same factor quantities as in the United States? We apply the same method to the problem as in the last one. In the first step, we use the Tangency rule to find the cost-minimizing bundle of labor and capital in the United States. Labor and capital are both 100. The cost is 1,000. In the second step, we use the same logic to find the optimal combination of inputs in Asia. We find that the cost of production is lower in Asia than in the United States. If it has to use the same factor quantities as in the United States, the cost will be higher. Notice that the minimum cost is lower in Asia in this exercise, but it is the same in the last exercise. The reason is that the production function in this exercise implies labor-intensive, whereas the production function in the last question does not. The wage reduction has a more significant effect on the firm's costs in this exercise. Thank you for solving all the exercises with me for this chapter. See you soon in the next chapter. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.